Hey guys, this is Mrs. Lyons, and the video that we're about to take a look at is going to show us how we draw covalent compounds, okay? And it's going to be important for us as we do this to think about valence electrons and how these interact, okay? So let's go ahead and get started. So covalent bonds occur because atoms are trying to satisfy the octet rule, which means that all atoms are going to be most stable when they have 8 valence electrons. So 8 electrons in that outer shell. Okay, the nonmetals and sometimes the metalloids, okay, are going to share their valence electrons with each other, okay, so that it's like they have 8 valence electrons. Okay, so if you think about fluorine is in group 17. Fluorine has 7 valence electrons. Okay, if we have the compound F2, all right, what we would do is we would draw our 2 fluorines, the Lewis dot structures, and then what's going to happen in these solo electrons, all right, are going to combine, all right, to form a covalent bond. Okay, and we're going to draw that covalent bond as a line between the 2 fluorine. We could also draw it just by including the 2 dots, okay, the 2 valence electrons between the fluorines. And what happens when we do this is, I'll get a couple of different colors of markers out. So what happens when we do this? Remember we said that each atom wants to have an octet, right? Well, when these electrons are shared, if you look, if I draw a box around this fluorine feels like it has 2, 4, 6, 8 valence electrons because of those shared valence electrons, all right? This fluorine, if I draw a box around it, also feels like it has 2, 4, 6, 8 electrons because those 2 electrons are shared between the 2 atoms. All right, so a couple of terms, all right. The paired up electrons are called shared, let's see, hold on. Electrons involved in bonding are called shared electrons. All right, and the paired up electrons are going to be what we call a covalent bond. Okay, and then another term that we'll get to eventually are these electrons that aren't involved in a bond. Those are called lone pairs, and that'll become important later this week. All right, there are a couple of exceptions to the octet rule. There's a couple of elements that we'll deal with that don't need 8 valence electrons to be stable. And those 2 are boron, which is happy if it has 6 electrons, and hydrogen, because it's so small, is happy with 2 valence electrons. All right, so here's what we do when we do this whole process of drawing our compounds. Okay, so the first thing we're going to do is we are going to draw the Lewis dot structure for all of the elements involved. All right, we're going to determine the central atom. All right, and 90% of the time it's the first one listed. All right, If it's not the first one listed, it would be the one with the smallest number of valence electrons. And this applies except hydrogen, okay? So hydrogen is kind of an oddball because it only needs 2 valence electrons. So it is never, just remember this, hydrogen is never going to be the central atom. All right, so then what we're going to do is we are going to combine any unpaired electrons. Okay, so any solo electrons. All right, and we're going to share those between the central atom. Whoops, my puppies are barking. Sorry about that. The central atom and the terminal atoms. All right, and once you get to doing this, it actually is kind of fun. Some of you will find that right away, and some of you will enjoy this, and some of you maybe won't get there, but it's kind of like a puzzle. All right, we need to put our pieces together so that everything fits. All right, so that every atom ends up with 8 electrons, including the 2 electrons that are in the bond. All right, so when you're done, we have to check our work and make sure everything has fulfilled the octet rule. Okay, so let's look at NCl3. All right, so if you look at your periodic table, nitrogen is in group 15, so it's got 5 valence electrons, and chlorine is in group 17, so it has 7 valence electrons. Okay, nitrogen is going to be in the middle. Okay, nitrogen, fewer valence electrons, so nitrogen is going to be in the middle. So I'm going to draw my nitrogen, and then I'm going to draw 1, 2, 3, 4, 5 valence electrons. Okay, and then I have 3 chlorines. All right, now you'll get better at this as you go, but you're going to want to put the terminal atoms on the sides of the nitrogen where there are solo electrons. It'll make your life easier. So I'm going to put a chlorine here, a chlorine here, and a chlorine here. Okay, and then each of my chlorine has to have 7 valence electrons. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now notice what I did. I left my solo electrons so that they're kind of facing each other. Okay, so we've drawn the Lewis structure. Now we're going to combine the solo electrons. By solo, we mean the ones that are just one on each side. Okay. All right. Okay, sorry about that. I was trying to get my puppies to calm down. Okay, so what we're going to do is we are going to combine our solo electrons. So I'm going to draw a loop around the solo electrons. Okay, so now we're going to redraw this. Okay, and that is going to be a requirement for you to do, is to redraw the structure, showing, instead of those loops, we're going to show them as lines, which are single bonds. So I'm going to redraw this like this. And you've got to include all of the non-bonding electrons as well as the ones that are in the bond. So this is going to be my final Lewis structure for NCl3. Okay, let's try another one. Now this one's a little bit tricky, but we're gonna take a shot at it. So this is SO2H2. Okay, so the first thing I want us to do is kind of take a look at the elements involved. Okay, so sulfur has 6 valence electrons. Okay, so 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons. And we have 2 of them, so I'm going to draw 2 of them. All right, and then we've got hydrogen, 2 hydrogens with 1 valence electron each. Okay, so now here's a trick, okay, that you need to start thinking about. Again, the more you do this, the easier it's going to be. But when you look at these elements, you can tell how many bonds they're going to want to make. They're going to make as many bonds as there are solo electrons. So sulfur wants to make 2 bonds. Oxygen wants to make 2 bonds. Hydrogen, though, only wants to make 1 bond because it's only got 1 solo electron, okay? So when we set this up, okay, we're going to keep in mind that those hydrogens are going to have to be the outermost atom, okay? So if you look at this, and the other thing to keep in mind is that bonds seem to form to give the molecules some symmetry. Okay, so for example, since there's 1 sulfur, 2 oxygens, 2 hydrogens, the sulfur is going to be in the middle, okay? And then I'm going to put an oxygen on each side and a hydrogen on each side, okay? Now, I know that because those hydrogens can't be anywhere except on the outermost side. So let's add in my electrons. 1, 2, 3, 4, 5, 6. All right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oops, and I didn't really leave enough room, but there's a bond for my hydrogen, or an electron. So this is how I would line this up. Okay, and then I'm going to loop the solo electrons. So if you see, I've got a pair here, I've got a pair here, I've got a pair here, and I've got a pair here. Okay, so that works out. And again, it's kind of like a puzzle, okay, where you have to figure out where the bonds go. But the more you practice, the more you will know. So let's draw this. So I've got hydrogen bonded to an oxygen, and I can't forget the lone pairs of electrons on that oxygen. And then there's a single bond, a line, between that oxygen and that sulfur. And then the other oxygen. And finally a bond to the hydrogen. Now, let's look at this and make sure that all of our atoms have an octet, except hydrogen, which only needs 2. So if I look, hydrogen, that bond counts as 2 electrons. So each of my hydrogens are in their most stable form because they each have 2 valence electrons. The oxygens, okay, if I look at the electrons that the oxygens have, all right, 1, 2, 3, 4, and then 5, 6, 7, 8. So that oxygen is happy. It has an octet. Same thing with this oxygen. 2 for the bond, 3, 4, 5, 6, 7, 8. Okay, so 8 valence electrons. And then finally, and you don't have to ever do this. I'm just doing this to kind of show you how I look at this to see. So the sulfur has 2, 4, 6, 8 valence electrons. Okay, so as you're looking at this, you want to count to see if the elements have the right number of valence electrons. All right, so this is going to be, we're going to do one more practice, and then I'll let you guys work on the other 7 for homework. All right, so let's do CF4. And I left you lots of room, and the reason for this is you can kind of draw your rough copy, your rough draft, and then your final structure. And I'm going to have you make sure, just to get in the routine. I know it's a lot of writing, but I am going to ask you to always write that final structure, okay, so that I can really tell that you know what you're doing. All right, so carbon. Carbon has 4 valence electrons. all right? And then fluorine's in group 17, so it has 1, 2, 3, 4, 5, 6, 7, 7 valence electrons. Now, I didn't draw that the way that you should draw that. If you keep in mind the way that we said to draw our Lewis structures, remember we put 1 electron on each side of the atom. So we've got 4 electrons before we ever double up. So fluorine has 7, so 4, 5, 6, 7. And I'm not real concerned in how you draw them. If you watched, I didn't draw that one at a time. Once you get used to it and you see that there's 7 electrons, what you're going to do is you're going to okay, 2, 4, 6, and 1 on the side. Okay, so CF4, carbon's going to be in the middle. So 1, 2, 3, 4. And then I have 4 fluorines, so I'm going to put 1 fluorine on each side of my carbon. And then I'm going to fill in the 7 valence electrons on each carbon, or excuse me, each fluorine atom. Okay, and when you do this, you notice, oops, I forgot an electron there. When you do this, you can kind of set it up so that your bonds all align, okay? But you know what? If you didn't set it up so that your bonds all align, that wouldn't be the end of the world either, okay? So let me just show you what you could also do as your rough draft. You could draw the carbon with 4 valence electrons, and then you could include your fluorines kind of all in one place. I mean, and that's why you have that rough draft, kind of, is so that it's like, oh, look, I can make a bond here, I can make a bond here, I can make a bond here, and I can make a bond here. So even if you don't draw it laid out neatly like I did, you can still figure out where those solo electrons are going to form bonds. So I'm going to form a bond here, I'm going to form a bond here, I'm going to form a bond here, and I'm going to form a bond here. A couple of things to just keep track of, okay? Symmetry. When molecules can be symmetrical, they're going to be symmetrical, okay? And molecules can't be formed with when there's not a solo electron, okay? So there's only so many ways that you can draw this, because for example, if you tried to do, let's say you tried to do this, like say you tried to bond these, this doesn't work, this is not right, because this is already a pair of electrons. That's why it's so important to draw your Lewis structure correctly, because then you link up those bonds where there are the solo electrons. The solo electrons tell you where you're going to form a bond. Okay? Now, if you draw this and you leave it at that, you're going to lose points, because you have to make sure that you include all of those lone pairs of electrons around each of the fluorine atoms. Okay, so this is going to be your final structure for CF4. Okay, so there are 7 other compounds for you to draw. All right, and that is what you should do for homework. All right, so you're going to go through number 8. All right, so I hope that kind of helped you see how we're going to draw these covalent compounds. I will see you in class. Take care of yourself.